thanks, and thanks for coming to my talk. So as you would have already gathered, it's about IPv6 and DNS and how Intinode are going to handle IPv6 reverse mappings for our ADSL customers. First up, a little bit about me. Ex-developer, or reformed developer as I sometimes say. At my last job I was a web developer doing mostly PHP, MySQL work. Now I've migrated on to being a system administrator at Intinode. Obviously I'm interested in IPv6, which is how I managed to talk my way onto the IPv6 project when it started up, and a few other bits and pieces. So Intinode is a broadband ISP in Australia, as I'm sure most of you already know. We consider ourselves a technical leader in a lot of areas. We were the first ISP in Australia to give ADSL 2+ to a customer, as far as I'm aware. And obviously IPv6, we have, right now if you have internet at home, you can go and get IPv6. And toasters. So I assume that most people are familiar with IPv4, IPv6, yes, mostly. So just for those that aren't, the top address is an IPv4 address. The middle address is the full form of an IPv4 address. Those two are V6. I am smart.
You want to run down a little bit?
Yeah. Can I have, this is just a practice run, right? You're not recording, are you? So that's the full form of an IPv6 address, really annoying and long. One of the things you can do is you can compact all the zeros together and strip out leading zeros in little sections, and you end up with something like that. On our network, all three of these go to the same place. But that's just because they do, not because they have to. Is everyone familiar with how DNS works? Yes. Is everyone familiar with how reverse DNS currently works?
Yes.
Everyone knows what the in-adder ARPA zone is? Put your hand up if you don't know what the in-adder ARPA zone is for. Okay, so I'll go through it fairly quickly because most people understand it. But so forwards DNS, how do I get to that? You send a query off and it does an A record lookup and you get an IPv4 address. You can instead send an IPv6 request, which is a quad A lookup. And I'd love to have been a fly on the wall when the decision was made to call it quad A. I presume it's to do with the fact that an A record returns 32 bits and a quad A returns 4 times as much, 128 bits. I'm sure there's more to it. Reverse DNS works almost exactly the same way. All you do is a PTR lookup instead of an A or a quad A lookup. In order to be able to handle delegations of address space properly in DNS, you actually write the addresses backwards from what you normally would as an address. So you can see the address here is 1 and 2, 231, 203, 132, and you can see the IPv6 address is perfectly backwards and under an IP6.ARPA zone instead of the in-adder ARPA zone. Is that enough for the people that didn't? Yeah. Moving on. Okay, so why do we want to do reverse DNS? So we're talking specifically here about for our customers, primarily ADSL customers. So why do we want to do it in the first place? Well, one obvious reason is for neatness. Having reverse DNS mappings means that when you do things like a trace route and it wants to resolve addresses, everything has a DNS name that you can use. Just looks cleaner. SMTP servers. So when a mail server on the internet is receiving a connection in, what it will typically do is it will do a reverse DNS lookup on the IP address it got the connection from. It'll take the result of that reverse DNS lookup, which is a host name, and then do a forwards DNS lookup again and make sure that the IP address it gets back is correct. This is just to verify that the host name that it's connecting from is accurate. There's not really, arguably, a good reason for doing that, but a long time ago when we were trying to fight spam, mail server admins started doing that because a lot of spam bots didn't have valid forwards and reverse mappings. But what it means now is that for anyone that has a mail server at their house or at their office that they want to run as an SMTP server on the public internet, they need to have these DNS mappings working. So if you want to run one at home and you've got IPv6 and you want to work over IPv6, you may well need to have a reverse DNS entry before all of the other mail servers on the internet will accept mail from you. And we were asked. I mean, it's as good as reason as any. What do we currently do for IPv4? For IPv4, we currently pre-generate, when we assign DSL ranges, pre-generate a static zone file with particularly formatted host names. Sometimes Yeah, we've changed the format of what we actually use for reverse DNS over the years, so you have to sort of get used to recognizing different ones, and that's a problem that we don't really want to keep if we can avoid it. Particularly different states and whether it's static or not, at the moment, everything just looks different, and there's no real good reason for it for the most part. Residential customers, we don't give a choice to at all about what their host name is. Static customers can come to us and request a change. Regular residential home users can't because their address might change on the next reconnection. And as I said, different naming schemes. Next time we get some IPv4 addresses, we might do it differently. So addresses. Addresses are the problem with IPv6. IPv6, the biggest selling point is bigger address space. Unfortunately for DNS and reverse DNS, which is what I'm talking about, that's kind of a problem because everyone has that many IP addresses. Every single person in this room, if they're with Internode, gets that many IP addresses each. Yeah, so if that's awesome, right? You know, so I have every machine in my room.
64?
Yeah, no, it's more.
56.
Because it's /56. And you actually get another /64 as well, but it's harder to use at the same time. There's also no difference between internal and external IPs anymore because it's all globally routable again, like it used to be in the olden days of the internet. And we don't know what you're actually doing on your network. You might change the network card in your server and its IP address might change. You can't come and, you know, it's not really practical for every single person to come and tell us, oh, my server IP changed because we changed the network card in it. We don't know if it's a new server, if it's an iPhone, if it's just a new laptop, if it's a friend visiting. So if we're going to provide some sort of solution, it has to be for everyone. Okay, so that leads on to the obvious realization that procedural generation is mandatory. We have to give back an answer based on the question. There's just no other way around it because we can't reasonably do this for everyone otherwise. There were a couple of options that we saw up front that we could potentially look at using. For different reasons, we excluded them. And then later on through the year after we started working on ours, a couple of others came out as well. So that didn't work. Just don't read the slides ahead. Okay. So we currently use bind for our authoritative name servers. Can we use the generate macro that's built into bind? Yay! Awesome, hey, so it's built-in functionality, it's already there, it's already present. No, we really can't. So one of the many issues with the generate macro is that it's actually a macro the same as in a C file. It statically generates the data in memory as it's read from disk. So we'd be using several terabytes of RAM per customer if we could actually make that work in the first place. No. So DLZ. So for those that don't know, Bind has a DLZ patch set which goes and adds things like LDAP and MySQL and Postgres support. Could we use that? Potentially, yes. We'd still need to go and write a backend for it, probably in C, although we may be able to do it in another language. We'd then also have to take on the extra maintenance of making sure that when an upstream Bind patch came out, that we were then patching the DLZ and our stuff on top of it, and then recompiling it and repackaging it and shipping it out. Kind of annoying, really. So why not the other things? Nothing seemed right. Not invented here. No, I really hope it's not that. I don't think it's that. We don't use PowerDNS. Most of the other options on the earlier page were PowerDNS plugins. Because we don't use PowerDNS, it means that in order for us to use them, we'd have to go and spin up PowerDNS just to run the plugins. And we still have other requirements that aren't met by the plugins that are there. So, yeah. So part of it really comes down to the fact that what we're really after hasn't been invented yet. One of the features that we need is delegation, which I'll get into a little bit more in a minute. I did it again. I'm just going to stand over here. We apologise for the unscheduled. So, delegation. With IPv4, we have a handful of IP addresses per customer. IPv6, obviously, we have a lot more. For a regular Soho customer, which is just a normal home customer but with a static IP and a couple of other bits and pieces, it's fairly reasonable just to have them ring up and say, I want my static IP address to say this. If we then have to deal with them ringing up and saying, well, I want this address to be this, and 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 then ring back the next month when their address has changed, that's not really as feasible for us to support. So a way around having to deal with handling that work ourselves is by handing it back to the user and putting them in control of their data. So instead we set up delegations to them, and they can tell us, these are my name servers that I control, that could be hosted at Amazon or on their own DSL or anywhere they want. And when we get a request for what their reverse mappings are, we just say, no, over there. It's the same way that the root hierarchy delegates to .NET, and .NET will delegate to on .NET, and so on and so forth. Static IPv6 for all. For those that aren't aware, Internode IPv6 allocations are static for all customer types, not just for the Soho and the business types, but for regular residential mum and dads as well. We worked out basically that address churn. You asking a question?
That's almost not. That's not what was said in the Internode. Here's how to set up your gateway, 6 gateway and router and advertisement.
Do you mean for ADSL?
For ADSL, yeah. Regular customers.
So the question was around the documentation that we've released previously. Depending on when you looked at that documentation, that may have changed. Okay. When we started the IPv6 trial 2 years ago and we started actually handing out the addresses, we were using a different network range, and we said that they're not static, they're stable addresses. And when we went into full production with IPv6 for ADSL, we did in fact change all those addresses once. But now that they have changed, the only time that your address range will change is if you take your DSL service and move it to another state. Okay. But that's really cool, because it means that people at home don't need to necessarily go and get static IP option packs and things like that to run static services, as long as you run them in IPv6 only. But that's cool, because everyone has IPv6, right? So what are we going to make the DNS mappings look like? This is one of the options. I think this was the first one that we came up with. I've used the IPv6 documentation prefix, for those that don't recognise it. So the address is at the top, and the next one down is obviously the host name that we automatically generate from the address. It's got the location in there, the state. We currently do that with our regular ADSL reverse DNS mappings. We've ended up not doing that for the production ones, mostly just because it's not really important or interesting data. If you want to know where it is, just do a trace route. It avoids us having to worry about renumbering ranges later between states. You'll notice it also misses off the 2001 0db8 prefix. Yeah, so one of the network engineers looked at that and said, you know, once upon a time we only had 1/16 for IPv4, and then we got another one. And the naming scheme for reverse DNS didn't match up. And so this is one of the things that we had earlier, is we didn't actually plan far enough ahead to be able to add, twice as many customers down the track. Just in case there's suddenly 40 million people in Australia next week. So what else could we do? We could do the sort of compression I mentioned, removing all the zeros, but the compression isn't necessarily canonical. So what I type in as a person may end up different to what the computer expects, and if I'm writing out an ECL file saying allow this host name, well, I should just be using the address. But you might get it wrong, and then the reverse mapping turns out something else, and there's just sort of, you get weird errors that way. You could remove the dashes, but I don't think we'd want to do that. Base 36. So this is one that seems to be really popular for other people that have implemented something similar to this. So instead of being hexadecimal, which is your 09A to F, it's 09A to Z. So it squishes it down into something that's about, I think it's 12 or 14 characters. Looks a bit like a password. In some ways it'd be a lot better, because it means that it is actually something that you could feasibly remember, and you could just SSH to a password and that would be your... We didn't end up doing that anyway. So potentially down the track, I mean, there's nothing that stops anyone from running a service that does the forwards mapping, which is the useful part of that. Taking a base 36 address and turning it into a usable IPv6 address could be done outside of our network. Question?
doesn't appear to be adding a huge amount of value given the fact that I've got a v6 address, and now you're telling me that it's a v6 address with that number and you're re-encoding the number, so that the useful data I pull out of that is the word static and internode. I probably could have got internode from the preforms. So I'm just curious as to why would you dynamically generate or template those things that were not explicitly delegated or special case?
Sure. So the question was, why would I bother doing this at all? Because it just looks exactly like the address, more or less. So there's a couple of reasons. One is that the internode part isn't necessarily obvious from the prefix, because we may end up sucking in prefixes from other places. So if a customer brings a /48 with them to us, you can then easily see from the reverse DNS lookup it's with us. You could still get the information by doing a trace or other things like that, but it just does put it in the one spot. But it mostly goes back to because we were asked. And the real reason we were asked by most people is to ensure that any MTAs that pop up on IPv6 don't say, oh, well, you don't have a reverse DNS record that matches your forwards DNS record, so we won't accept mail. So.
Sure, but having run mail service, the reverse turned out to be a fairly poor signal over time.
I totally agree.
The better signal is
it doesn't matter how poor the signal is if a large ISP rejects all your email.
Yeah. I've found, in my experience, SORBs to be a really poor signal of
Here.
SORBs dollar list is a good signal.
Yes. Unfortunately, a lot of people use the other list as well. But anyway, so I'm happy to talk to you more about it, but it basically comes down to we were asked, and people are really concerned about mail servers not accepting mail. And OCD. Yeah, what's wrong with OCD? We're geeks here, aren't we? So the proof of concept was in Python, and so why Python? Python because it's easy to use, easy to pick up, works really nicely, and it fails really well. So the core of the Python DNS server that we took, which I'll go into more detail on later, on the outside part of it where it's handling almost everything, just has a try block. And at the end of it, if you've screwed anything up along the process, it returns a serve failback. Which means when I was sort of doing some of the proof of concept testing and I was sort of doing some mangling on strings and arrays and things like that, I did what every C program hates and tried to access an array out of bounds, and I just get back a serve file straight away. So, ooh, that's actually kind of nice. Downsides, so performance maybe. We've done a benchmark, it says it does more than enough traffic for us. At least for now, we don't foresee it being a problem. Who knows if it could be improved by moving to another language. Internal support is probably the slightly bigger issue. There's not as many people inside Internode that know Python as know a language like Perl. I could have used Perl, but Python is easier for me to hack away at random stuff in. And in some ways, Perl seems like a more natural choice as well, because a lot of it's sort of mangling of strings and returning the same result differently. You think, oh, well, Perl's got the native regex handling built into the syntax, but Python's regex class is actually really quite useful anyway, and I found it to be really good to work with. Right, so integrating into our existing DNS systems, how are we going to do it? The first option we looked at was DNS forwarding. So that's basically reverse proxies like Squid, except for DNS. It was a really good idea. It meant that we could run our automatic mapping servers on a different private network, which meant they didn't have to be exposed to the internet, have to worry even less about security over time. Unfortunately, it's not RFC compliant, because bind won't return the AA or authoritative flag if it's set up in forwarding mode. Among other things, the current LTS version of Ubuntu still ships a version of bind that will ignore queries if they don't have that flag set and they're supposed to. Yeah, and you have to worry about caching, because then our authoritative name servers are suddenly caching things, which they haven't been previously. So at the moment they've got a reasonably low memory allocation, and it's static because we know how many zones they have and how much data they have. Not a huge issue because we don't actually see a huge amount of traffic on reverse lookups, particularly at the moment on v6. Sure.
So the obvious DOS, just walk a /20.
Yep. Like I said, so it's possible. We haven't had any problems. we can actually handle quite a lot of traffic to them, and we can handle more traffic to the automatic DNS mapping servers than we actually get regularly across our entire DNS infrastructure put together. So yeah, delegation is the obvious solution to the real problem. So instead of having our automatic servers sitting behind our real servers, the real servers just say, no, that's an ADSL reverse range, go over there. This ties into, if you were looking in the examples earlier, the static to IPv6 zone means that we can delegate that entire forward zone to the automatic mapping servers. This means that we don't have to worry about having existing data in that zone or collisions with other things. That's just dedicated for the purpose. PyMDS. So PyMDS is an existing modular standalone Python DNS name server. It was developed by Tom Pinkney. We've added a new backend to it for doing IPv6 auto mapping and a plugin for handling the delegations. Really simple architecture. So the request comes in. It gets better. The request comes in, and based on the zone name that's configured, it chooses the right backend plugin to handle it. It actually gets a little bit more complicated, but not much. And it goes right back and plug in. If you'd like to chat on IRC and debate my code quality in Python, this is the URL you can download it from. So feel free to pull it apart and critiques and send patches. Sorry? Sure. It's bigger on the laptop. So it's users.on.net//amebus/pymds. And I'm sure someone that can read it from the front row can post it to IRC or Twitter or something if they want. So the backends. The existing backend was file, which just loaded a very simple plain text zone file off disk and then served the responses. We've added another one which just does the automatic mapping, both forwards and backwards, and hands that back instead.
Is there an ordering for that? So it looks for the file first and then...
No, it's one plugin per zone. So you have one...
One plugin per what?
You have one plugin per zone. When you configure the name server, you say for this zone, this is the plugin to load the data. Here's some extra data to give that plugin, which might be the file name. Or in the case of this, it'll be the forwards and reverse ranges that it should be responsible for. And yeah, like I said, it started with just plain string munging, moved on to regexes. I really quite like Python's RE module. I didn't think I was going to, but I did. Just because I'm a little bit used to Perls and awk and sed being sysadmin. So the other thing we use out of Python standard library is Python IP adder, which we use for just handling the address manipulations, getting binary data out. It also acts as a good sanity check to make sure that we're not doing totally bogus things. This is the core of the code. So it actually ended up being really, really simple. Obviously, there's a lot of stuff around this to make it do DNS things. But yeah, the only thing that I'd say took any real trickiness was this line I used to do as array munging and strings, and I suddenly realized I'm sure there's a way to do that with regexes. And indeed there was, so it just replaces every set of 4 characters with 4 characters and dash, limits it to 7 because there's 8 groups and you don't want to dash on the end because that would just be embarrassing. And we've got delegations. So before we go and write a plugin to do it in PyMDS, is there a reason we can't just do it in bind? So in the zone file that hands over, say, 2001-44B801 to the automatic name servers, surely if you just say 2044B801-0000, it can go to this other name server. No, bind just ignores the entry. So we could have a zone file per customer and then delegate within that zone file each of their ranges, or within the 50/56, we could delegate each of the /60s over to them. It gets a little bit awkward, but it does work. You can use wildcards to keep the number of entries low, but you're still adding one zone per customer, which starts to be a bit of a high overhead compared to the number of zones we're running. We could put in the AutoMagic backend itself, if we wanted to. It's kind of a bit messy doing it that way. We could do it really cleverly. We could drive it out of our IPAM system, our IP address management system, and we could just have it so that when a new DSL customer is provisioned, they get an IPv6 range allocated to them, an entry gets written to DNS. If they get their DSL servers deprovisioned, we remove that address. If they add name servers, we just change that, except the IPAM system doesn't know about DNS entries, which means we'd have to have another system that knew about the DNS entries that could integrate with the IPAM system, and it just starts getting sort of complicated. And cleverness and timeliness don't always go hand in hand. So the solution is a filter. PyMDS has an RR filter, which is used for doing random reordering of the result sets. This duplicates the behaviour that you typically see out of a name server. It stops the first address return from always being the one hit by clients that are silly. So we made a new backend called override. The config's reloadable, it's separate code. It removes the quad A answers and drops in NS records instead whenever it finds an entry that matches. When the config is ready, and it actually statically populates a hash in Python, so the lookup's fairly fast as well. It did require a small API change to the application we used in order for it to support NS record munging instead of just handling, or rather the authority munging, which is how the NS records are returned, rather than just the answer munging, because DNS responses are made up of a question section, an answer section, an authority section, and so on. So, filters. So every zone file that's configured has a backend plugin and then potentially a series of filter plugins. And then the response goes back to the internet. So on the topic of NS records, when we were first handing back delegations for customer ranges, one of the issues we noticed was that the authority section would say, yes, this IP address, the reverse lookup can actually be found over there, and correctly point to the customer service. Everything worked, but because it was saying that specific address is authoritatively handled over there, instead of this whole range is, it meant that in the event someone was trying to map out, a large number of servers in their own network, say, at home, that every single time they would come back to us and say, oh, I'm looking for the reverse entry for this IP address. And we'd say, it's over on that network. And they'd come back and ask again, we'd say it's over there. By fixing the level that we handed back the authority at, it meant they had to come to us once and we said, oh, not only is that address over there, but that whole network handles DNS.
Wouldn't that require the customer to actually have a zone for the /128?
No, because
If had a /56 zone, technically it's not a valid delegation.
it is, because the query doesn't get split in half. When the resolver is actually sending a query to authoritative name server, each of the segments of the /128 are still sent. They're not split into, here's the host part I'm looking for and here's the authority part. The query is just for the whole lot.
I understand that it'll work, but it's technically not a valid delegation. If you check the delegation, the NS records won't match. Because they'll have the NS records for the /56 and you've told someone that NS records are the /128.
Yeah.
No
It quite possibly violates the RFCs. We fixed this anyway.
Okay.
But it did actually work. So it's amazing sometimes what works with DNS. And moving on from that, query types. So there were a bunch of query types the original prototype didn't handle. And everything looks okay, and then you start running into things that don't work. One of them was the host command. Host space and then one of the host names. And it comes back and it says, oh, there's no such record. I'm sure there was. You do a dig for it manually, and yes, it works. Then you realise the host command will send an A request, a quad A request, and an MX request. And the code was being really stupid and was returning an X domain instead of just not returning any data. And so there's a really big difference between saying there's no such domain and just saying there's no data. The difference being that if there's no such domain, that means there's no data for that host name at all. So in the event that I ask for an A record and you say back to me, there's no such domain, I will then know that there's no such quad A record or MX record or anything else. But if I query directly for it, I'll get the right answer, the case gets populated and thinks it's okay, and then you get weird output from host like NX domain, the host cannot be found, but here's its IP address. To say that's confusing would be an understatement. The other thing is the any query type, which returns IPv4 or IPv6 or both, depending on what's available. So we handle that now as well, only ever by returning a quad A record, because obviously we don't have IPv4 mappings for them. The other one that was interesting was NS records. So you could do a dig plus trace or something like that, and it would trace through the whole path. And it would get to the automatic mapping servers, then it would go onto the customer servers because it was delegated. But if you actually ask the mapping servers where the name servers were for that network, it would say, no, there aren't any. Because we weren't correctly handling the NS record type. It's still critical to handle all of the different record types, no matter whether you're actually trying to do something with them or not, just to make sure that all of the client libraries and resolvers don't get confused. And the MX still isn't actually handled in our production boxes. The code at the bottom is slightly newer than what we're running in production, because I committed it this morning. On the day we started going to production, with the version we're running now, one of the network admins came over to me and said, it'd be so ironic, wouldn't it? I said, what? Oh, if this magic IPv6 DNS mapping thing didn't work over IPv6, I love you, Python. So it's one line change. Awesome. So you just change AFINet when you're creating the socket to AFINet 6. IPv6 for all, IPv6 all the things. But it was IPv6 only on some machines. So it turns out there's this sysctl called net IPv6 bind v6 only. And on some distros, on some versions, the default's 0, and on some distros and some versions, the default's 1. And on some operating systems, you can't change it at all. And if you're not root, you can't change it at all. So either you set it to 0, because it's your box and your root and you don't care, or you do the right thing and in the code you can actually say, yes, I know I'm asking for v6, but don't limit me to just IPv6. Because what was happening is, and I was coming into this when I was trying to write the demo for the talk, it would bind to localhost, but it would only bind to the IPv6 localhost. So you'd tell it to bind to localhost and then dig at 127.0.0.1, and it didn't work. That joke was his. Yay, all done, everything works, except I'm a sysadmin, so I get the other fun stuff as well, deployment, monitoring, testing, security, scaling. So, hey, sysadmins unite, after we've finished fixing the server. So deployment's really simple. The code, as it stands, is in Git internally. We use deb build to build Debian packages out of it, roll it out to a custom internal repository that we build with ReproPro, and we use Puppet to make sure the servers are all built correctly, to spec, have the right config, and start the daemon and stuff like that. Puppet we don't use for handling the customer data. We have a central DNS management system that can push things out, which will deal with about half the customer data at the moment. You're ruining the jokes and everything. So monitoring, we use a combination of Mon and Nagios. If you're looking at Mon, considering using it, don't. The nice thing about both of them is you can write shell scripts that will work equally well, or depending on how you call it, equally poorly, in both environments. So we've written them and they run currently in Mon, but we can easily enough port them to Nagios. Oh, come on, that was worth a laugh, wasn't it? So in way of testing it, we didn't write formal unit tests in Python because I kind of ran out of time. But what we did is we did dig for a bunch of stuff, and we just have a bunch of queries that are regular queries that we know what the result should look like. We grep out a whole bunch of the dig output, pipe it into a file, compare it to a known good file, and hurrah, we have regression testing. It's dependent on the version of dig. So I upgraded my machine and all of a sudden all of my tests broke. It's fairly limited in other ways. One of them is that it can't handle things like the NS rotation. So when we return a delegation, we'll sometimes return NS1, then NS2, and sometimes we return NS2, then NS1. We get around that by only returning 1 in the test case.
Plus short, plus sort?
Yes.
Plus short, plus sort?
Plus short does not work for us because plus short will ignore the authority data and not print it out. But we specifically care that the authority data is correct and not doing stupid things like returning the /128 as authoritative.
Plus AAL?
Or ignore dig and use a Python class library that's...
Yeah.
Yes, there are a number of ways to solve it. The one that I did in 5 minutes was this one. Feel free to contribute. So security, the number one security thing we did was not make it have to run as root. Binding to port 53 is a privileged port. You have to run as root, at least when you're doing the bind. So it was a very, very small change, thank you Python again, for being able to actually move where the bind call is happening to somewhere so we can do the bind, then drop privileges and not have to worry quite so much about it. Down the track, something like UpArmor or SE Linux would be really good, but right now we're not too concerned about it. Scaling, so there's 2 really obvious things that are going to have to scale over time. One of them is just handling more queries. as IPv6 picks up, more people are going to be using it, more people are going to be doing reverse DNS lookups. So obviously, we need to scale that. Really easy, you add more boxes. Delegation. So as the number of delegations grow up, I mentioned before, they're loaded whenever the configuration file changes and statically precompiled as almost the right data to return straight away. There's very little that we have to do to it before returning it. It's put into a hash. Makes it really quick at runtime. Does mean that the memory usage will scale pretty much linearly with the number of people we actually have using it. For delegations specifically. Customers that aren't doing delegations don't count towards the memory usage. The obvious thing, put more memory in.
How many delegations have you got?
Right now only a handful because they're being done by hand. We are working on back-end tools to automate the process. If you have an IPv6 service with us, you can send me an email or drop a ticket into the support line and we can sort that out. We haven't yet advertised it anywhere except for really on Whirlpool, just because it's sort of a bit awkward at the moment. But it is definitely coming. The real way to handle delegation scaling is just to say, okay, well, I'm going to have 2 servers over here and that will handle the eastern states, and 2 servers over here and this can handle the rest. Split it down the middle in the central DNS management system. Bob's your uncle. We're going to run out of time?
15 minutes, just under 15.
Oh, heaps. Is that before talking?
This is including questions.
Cool, that's perfect. So we could be clever, we could move to Bind instead, we could do the nifty IPAM integration stuff, or find other solutions.
You could also, presume partly do something like close the DB file, you could potentially just take your data and have it on this, when the lookup is then still a deep lookup like it is now.
We could quite readily move to using DBMs or move to using SQLi or something of that nature. Wouldn't be a problem. Partitioning is the solution we can do without actually changing any code, which is the reason I mentioned it. But yeah, no, you're totally right. So in the future, maintain versus replace. Do we actually want to keep maintaining this internally ourselves? Well, obviously, if you all go back and start hacking on it, we don't have to worry about that. By all means, everyone, download the code. Maybe we'll replace it down the track. Maybe one of the other projects, like the Power DNS plugins, will take over the world and we'll just start using that instead. If we do start using that instead, how are we going to manage the naming convention that we've already established? Because some people will undoubtedly have come to rely on it. It's almost like an API, but for residential, normal people. And obviously we've got the problem of delegations again. We still have to have some way of managing that. Ways around it, obviously. So I just want to, before I totally finish up, give a few thanks. One to Tom Pinkney for writing PyMDS in the first place. One to Michael Davies for convincing me to actually lodge this talk. One to OCA for accepting my presentation proposal. And one to Internode for being A, awesome enough to let me do this, even though there's no dollar signs attached to it. And B, for being cool enough to let me release it as MIT. We've got a couple of minutes left, so does anyone want me to risk a live trial?
Sure.
Or are there more questions? I'm happy to do either. I think you were first.
If you have
It's just really quiet.
if you have requirements for
particular business users perhaps, or people with their own business names that you want to reverse map, yeah, sort that out in the code there? Or?
Do you mean for handling dynamic reverse mapping for them, or just doing their their allocations statically?
Oh, doing their doing their allocations and just keeping them there.
Because that's a good point. I was supposed to mention in one of the earlier slides. So for a customer that say, maybe a big corporate customer, they come to us and they say, we don't want to have to worry about running our own name servers. Yes, if we load a zone that matches their /48/56 or whatever into our main authoritative name servers, that full zone will actually take precedence over the one that sends them off to the mapping servers. Okay. Because Bind can handle that natively at that level, so it just sends the answer straight back. So if we want to statically manage a zone for a customer, we can still do that.
There's still a whopping great load of other addresses that you still need to somehow either map or do something with. You'd still have a massive zone file, wouldn't you?
Potentially, it depends on why they want to do it. If they just want to say, this particular /64 is for our servers, we can handle just that /64 and hand the rest back to the automatic mapping server. If they want to say this small part of our network has a server on it, we can just have, you know, a fairly fine level delegation that says, no, just send that handful of addresses off to the automatic mapping servers. We can still handle it with delegation if we need to.
That's a lot of overhead for you.
It would be a lot of overhead, but no one's asked for that.
One more thing. With IPv4, we have ranges of 28, 256.
Just turn it off.
Can we get the lights turned down? So we can see the screen?
Thank you. With IPv4 pointer records, we have 256 records per zone. Yep. What about with IPv6? Is it fixed like that, or
It's not really fixed in either. You can still do delegations down to the individual IP address. It's just sort of a bit awkward looking. The easiest place to handle a zone file is not necessarily at one particular point, but on any nibble boundary. So the nibble boundaries are where the dots are put in the reverse lookup. So that means you could have 16 in a single zone file, or you could have, you know, a zone file that in theory covers 16 billion addresses. You just wouldn't want a zone file that actually had 16 billion addresses in it.
Okay.
Question. Have you got any plan for handling DNSSEC?
In general, or with this?
With this in particular?
Not at this point.
In general? Accepting patches?
And I forgot to run update server info so the git clone doesn't work. Yes and no. Yes, it's something we'd very much like to do. It's not currently scheduled. And on with the live Nepo.
I think I considered doing it actually.
Any more questions?
That's better.
Maybe a little bit of a silly question. I haven't yet done my research into IPv6 reverse, but wildcard and not caring if it forward resolves, because if you're running a mail server, you should be running your own and delegating to those customers who are running their own DNS?
Yes, but it adds a lot more complexity for the customer who cares enough to run a mail server but not enough to run a DNS server.
Yeah, but as sysadmins, don't we want those customers to learn?
As a sysadmin in ISP, I've seen what happens when they learn badly.
Fair point.
So it basically comes back down to, we were asked to do this by our customers. It wasn't a large number of people, but this being IPv6, there's never going to be a large number of people at the moment because we're still trying to get people interested in doing it. So for my example, if there's no one else that wants a question, so this is the authoritative name server running, and I can do a dig. And so you can see a bunch of debugging output, and it returns a PTR of nothing because I've broken it.
No, just return.
Where is it? Oh, there it is. Ah. I hate typing in front of an audience. So you can see there that it returns the address again. And I have delegated that's an example of a delegation that happens. And you can see if you ask for an A record or an MX record that it says no error, but it does not actually return any data, just as empty question section. Any more questions?
So this is all in production now, and I can go and take that, clone that code and run it on my network, which Internode have delegated to me already, and it'll look exactly the same but with my domain.
Yep. So the web page, if you actually get it to load up, looks like that. So there's example config that I've put in with it. There's a tarball or a git tree that you can pull down. The reason it didn't work for me before is because I forgot the URL And you can pretty easily work out how the config works, I think. A little bit bigger. Well, it can't be a broken link because it's text only, right? All right, thanks for coming. And
Yep, just on behalf of Linux.conf.au, I would like to thank our presenter, Robert.
Thank you.
Thank you very much. And just before everybody trots off, just an announcement from the organisers. Just a short while ago, while that talk was in session, it's been announced that it's now a total fire ban, so no naked flames outside.